Hi there, this is Shayon, and this video is about dark field microscopy. Now, how the image formations in dark field microscopy happens, and how the dark field microscopy actually differs as compared to the bright field microscopy. That is the topic to discuss in this video. So in some previous video we have discussed the whole principle, the image formation principle, how the microscopy works, dark field microscopy. You can see that one, and that will be more helpful to get the whole understanding. Okay, so now we know dark field microscopy has the unique advantage that we don't need any staining. We don't need any staining for the particular organelle. So whenever you have the situation like that, you want to make some imaging experiment where you can't stain your organelle of your cell, because it may staining may can some disadvantage, means that staining may alter the functions of that particular organelle, and in that case staining will not work. So if you have that type of situation, dark field microscopy is the only options. Among the whole branch of microscopy, dark field microscopy is the only technique. And in next, phase contrast microscopy. So these are only technique where you can see you don't have to stain. You just take the cell and put in the cell specimen plate and image it. Okay. So now how this image formation happens? That's the main important point. So as we have said that the objective, eyepiece, and any other condenser lens, that are the main part of a microscopy. Main part is the specimen plate where specimen are kept. Another is the objective where your emitted light from the specimen are going to be collected, and there is a condenser lens, and this condenser lens is actually to convert your light beam into a well manner focused beam. Okay, so these three parts, objective, specimen, and condenser, these are important to note in the case of bright field as well as dark field. So the main difference lies here. You have the excitation, you have the excitation light, and this excitation light going to be passed through the condenser lens for every microscope. Now what happens in dark field microscopy, they use a special type of condenser lens. Here you can see here this is the special type of condenser lens which use a plate where you have a hole which only allow the edge light, not allow the light of the central part. So the condenser lens will not allow the light of the central part of the light beam, which only allow the edge portions of your light beam. That's why you can see here in the bright field microscopy, or you can consider the wide field light microscopy, the whole light beam are going to fall on the specimen, and it will excite all the atoms in the specimen, all the electrons. And in dark field microscopy, here you can see that you have a vacant place, you have a white place here. Here there are no light, here. Only light is going in this edge, light is going from this edge, because the central light is going to be blocked by some special type of condenser lens. So special type of condenser lens is nothing but a opaque disc. You can see here that this is the main part to consider. This is the main engineered part for the dark field microscopy. Okay, so you have a light source, and then you have a collector, and then central aperture. The central aperture is the main role to play. Okay, central aperture blocks the central beam. The central part of the beam is blocked by the central aperture, and you can see this yellow dotted border yellow part is actually the edge light are going to come and falls on the specimen, and then the next things happens. So two types of engineering are there, two steps engineering are there in the dark field microscopy. One is the engineering at blocking central part by the central aperture, and next engineering is the objective aperture. We are coming to that. Now the question is why the central part of the being are going to be blocked. That are real good questions. Okay, so that you have to know. Whenever a central part are coming, it will fall on the specimen, and then when it will emit light, it will not make any interactions. Whatever the central part are going to be collected in the image plane, which is coming from the specimen, that actually are just undiffracted light. So when one light is undiffracted, that will not making any interactions with your specimen, then what is the information this light have? It has no information, okay, for the specimen. So only the diffracted light from your specimen, coming from your specimen, can possess some spatial as well as temporal information of your specimen. So whenever you don't have any informations, why you were considering that light? That the people thought. They thought, I will not take any light which doesn't contain any information. So the central part does not contain any information. That's why they try to block the central part of the light beam, and that has been done by the first blocked central beam. And in next portion, what is happening, whenever light is coming from the specimen, see carefully, this yellow color black dot border is actually the light which is coming from directly the light source. See, this is the light source coming, this light source is coming. So this light after the specimen is going to be follow this path. So this path and this path. Now the edge ray, the beam path of the edge is actually doesn't contain any information, because that is coming exactly from the light source. That's why you don't need that light. That's why that also you have to block. That is blocked by using objective aperture, where you can see here the objective aperture is used to block the light which is directly coming from the light source. Okay, so direct light, here you can see the direct light from the light source is actually blocked by the objective aperture. So two engineering are there. First, central beam will be blocked by using a central aperture. Next, direct light from the light source, is going to be blocked by the objective aperture. Now here is the light which is diffracted by the specimen, that only contains the whole bunch of information, spatially as well as temporally, and that will going to be collected by the image plane. That will going to be collected in the image plane and make a dark field image. And special condenser here actually is made up by the central disk, by that opaque disk which has a central aperture system, which blocks the light that would enter the lens directly. Here you can see the block the light that would enter the lens directly. Okay, so two engineering are there to block the central part of the beam. Another is to block the light which is directly coming from the light source. That's all about the microscopic technique part. Okay, now we will see in an interactive video where you can see in more details. This is the platform where image are going to be collected. This is the lenses, and these are the plate. See again, these are the plate. Here you can see these are the lenses. Yeah. These are the plate. These are the phase ring, called a phase ring. This phase ring, see very carefully, in the phase ring the inner portions are completely black and the outer portions also completely black, but there is a hole between the inner portions and outer portions. So whatever gap exists between the inner portions of the disc and the outer portions of the disc can allow light to pass through. So after the light, after passing through this phase ring, only will contain the edge part, no central part will be contained. That's why you can see in the video, it will block the central part. It will block the central part of the light. Okay, that you can see the video. This is the light source. Now this is the projector where image will be collected. Now light is coming. See here the central part is going to be blocked. Now this is the ray path. Now specimen will come. This is the specimen are coming. White part is the specimen. Now emitted light are going to be passed through the objective aperture, and the image of the sample appears to the screen. That's all about dark field microscopy technique. See again the video so that I can tell you once more. This is the platform where image are going to be recorded, and this consists of detector, this lens to magnify, this is the phase ring, which is very important thing, and then you have a projector to collect the image. Now light ray is coming. After that, after the face plate, no central light will be there. No central light will be there. Now specimen is coming. This white color is the specimen. Is going through the objective aperture. The emitted light from the specimen are going to make an image. This image appears of the sample appears on the screen, where you can see in that projector. That's all about dark field microscopy. Hope you understood all the concept. If you have any doubt, you can just ask me, You can make comment in the comment box. I want at least 5 to 10 comments, 5 to 10 questions in the dark field microscopy. I will happy to answer that one. And I have given my mail also. If you have any query, you can send me mail also. Thank you for watching. Bye bye.